The other thing I should mention is that this video is probably going to be not as good quality as the other ones are, because the problem is it takes it at a lot higher quality, so I have to reduce the quality to get it to run fast enough online. But I might be able to do it. I've got a different strategy now, so I might be able to do it. Today I want to introduce you to a couple things. We've already talked about getting the computer to talk to us. We type something, the computer says it back to us. I'd like to show you today how to say something to the computer and it will type back what you said. It will analyze it. It's a speech recognition program. And it's really quite good, very impressive. You can speak with your mouth full of corn dogs or whatever. It seems to understand what you're saying, so I was impressed with it anyway. And what I've got is some programs, a basic program, fundamental one, that allows you to do that. It allows you to make, in any program you have, if you wanted to do this, you could say make the program so that I can talk to it, so a person can talk to it, and it would do something. Now normally, the first step, of course, is simple. You simply say, well, hello, my name is Joe, and then it prints out, hello, my name is Joe. Whatever you say, it just prints it out on the screen. That's the simplest of all programs, because what it means is Google listens to you, sends you back the text, and you put the text on the screen so the person can see it. That's all that's going on there. But you can also take that text, that whatever they're saying, and because they translate it into text, there's ways of looking at that text to see what words they used, and you can actually find out if they say certain things. We'll be doing that. We'll start next class, but next week we'll be doing a lot of it. It's called the if statement. It's the thing that made the computer really work. Without the if statement, there is no programming. Programming doesn't do anything. It's, as you can say, do this, do that. You can have a robot saying turn left, turn right, turn here, turn there. You can have it do anything. But you can't, without the if statement, you can't say, if that's a step, put your foot up higher. Or if that's a wall, don't go forward. And as you say, if something is true under these circumstances, do something different. And that if statement is what made the computer really work. Without that, there was nothing. There was arithmetic and a bunch of series of do this, do that, do the other thing. But that's what put the intelligence into programming. So what I want to do is, before we get to that stage, I would like to have you be able to look at text when someone says something, to look at the text to see, to make it turn into text so that you'll understand that that's what you're working with. They say something, you get text, and then that's the text that you have to work with. You can look for things in it and be able to do that, okay? So the first step, before I even do that though, I'm going to go a step beyond here. I'm going to go a different direction. What I want to do is, last time we talked, we had a different set of programs, and they were related to the computer making noises or talking to you, okay, which is the easier of the processes. What I'd like to do today is, I'd like to write a little program that uses that process, just to show you a program that uses it. The previous one, all we simply did is, it was very simple. We typed something, and the computer said it. Type something, the computer said it. So basically what the program did is you have an input line, you send the input line off to Google, and it says it to you. It was a simple program. But what I'd like to do now is, supposing what you want to do is something slightly different. Supposing, for example, you wanted to translate whatever people said. This is sort of a humorous translation, it's not real. Suppose you want to translate what people say into Canadian, okay? So you say hello, and they say hello, eh? you say no matter what you say, they just say eh at the end of it. That's the translation. Now, originally, what I used to do early on, before I realized it's too hard a program to write, I used to do one that would translate stuff into Pig Latin. You know what Pig Latin is? Pig Latin is like if you say a word that ends in a vowel, you add the first letter to it, and then AY. So for example, banana, for example, you add the B to the end, and then you add AY to that. So banana is ananabase. So in other words, you pull that first letter and you add something to the end of it. And if it ends in a consonant, you just simply add the AY. You don't have to add the first letter to it. But to do that actually is exactly the same thing. You could say to somebody, say something or type something or say something, and it would give you back the translation. But you have to check to see if it's a vowel or consonant. We don't have that yet. We have to make that check starting next week. So basically, we don't have a way to deal with that. So what I thought I'd do is do one that's very simple. Basically, whatever they say, say to the computer, let's see, this one here, actually the computer does the talking. We don't do the talking. Whatever they type to the computer, it goes in and it adds a Y to it, and then it says it to you. So in other words, it talks to you, but it talks to you based on what you type in, and it adds a Y to it. Does that make sense? So it's kind of a simple program. Whatever you say normally would say back to you. Now it's going to say whatever you say, whatever you type, it's going to add a Y to it, and it's going to say it back to you. So it's generating sound, okay? It's a voice synthesizer, just like we did last week. So it starts off with, we got HTML. I'm going to try to squeeze this a little bit by putting these things side by side to see what happens. And these things could be underneath each other, but I'm putting them up here because I got this board I have so much board to work with. And then I'm going to add this guy right here. Well, I'll add it down here because we look at that over there. Script. Now this is the script that's going to take whatever you type to it and turn it into sound and send it back to you. Right? This is the function that does that. The script is leave a space there. And the source, you have to name the file that the source is in. I'm going to just write, it would be .works.com. You can write new talk. .js. That's the file. That right there contains the Google stuff that changes text into voice. Okay. Now I'm going to remind you one more time. A source, this is actually the actual file that contains the stuff. But you might see it online. If you list a program that does this online, you might see http://.works.com/this. So in other words, I give you the entire pathway sometimes because it depends on what I'm doing, what I'm trying to accomplish. In this case right here, we just write on the board, we just want to, this is the files doing the work. It happens to be in my site. So I put http:// and all that in front of it. But it's just that's the file we're talking about here. So that contains the programming that when you type something in, it goes to it. It knows that you want to say that, so it says it out loud. And that's what that contains the program that does that. Okay? Then we have the program itself that we're writing. Now here's going to be the function that does the work for us, okay? Like that function. The function is going to be called, I'm going to call it trans, just like the translator, just use it calling it that. Function. Trans. So what that's going to do is it's going to translate the English expression we write to it into Canadian. It's going to say it to us. So trans, and I'm going to send up a phrase. This phrase is coming from down below. So we have something like this. Screen, like so. We have a place to type in stuff. We're going to have a place to type in stuff. And then a button that says translate. So basically I press that button, it goes up to this function, and it goes to Google and translates it for us. Okay.
And is it speaking it out loud in this case?
What?
Would it be speaking it out loud in this case versus just, or will it just be displaying the translated?
No, we'll say it to us.
Okay. Switch speech
retype,
to text,
it
it's
talks.
text to speech.
Yeah, this is the one, this is from last week, where we type and it talks.
Okay.
I call the Canadian, this is just, I just made this up. Capital C, you know, because Canadian equals phrase, whatever they type in. Now this is right here, you've seen this before, earlier in this course, but I'm going to put it in again. Plus, quote, space, A. And so, that's what that does. Whatever we say below is going to go into it. Whatever we type in is in the expression called phrase. It's a variable. So we send that phrase up to us. And I say, take that phrase and add A space A to it, okay? It turns out that if you put EH, it doesn't say it correctly. Because EH is an A, it's not a word. So it doesn't know what to do. But when it sees the A, it goes A. It does say it. It's kind of awkward, but it works. So in other words, this phrase, if I say hello, what will happen now is it'll say hello, A, like that. It'll add them together. I'm adding the actual quotes. I'm putting that actual stuff together with whatever's in the phrase and putting it in Canadian. So our Canadian is the translation, basically. So then what I say is I want to send it up to Google to have them say it. So I'd say with accent, because you have to tell it which language you're going to talk to it in. We say, first of all, this right here is just a variable, just that variable. Both of those guys are now in here. I say Canadian. I'm sending that up there as the word that's going to be translated. And then I put EN, and assign US, like that. Now, here's what I've done. This thing right here is a function up in this guy. So I'm saying is, into that function, send this variable right here, which contains whatever we said down below, plus A. So that gets sent up there. So now it receives it, and I say I want to say it in American English. And that does it. That says that does the job. That will say it right. So whatever you sent up to it, it's going to, now the question is, how do we set this up so we say the phrase right here, and put a button, so we press it, it goes up to this function, it does the job for us. So right here, /script, /header, and I'm going to put the body here too, body and style, center the whole thing. So those guys could be on different lines, but I put them all on the same line right there. So now we're in the body, and the first thing I want to do is I want to put this right here, a place for us to type in stuff. So I put it up there, I call it input. Type equals text. Text. And I have to give it an ID, so I'll say, call it words. I'll just give it any old idea, make it what it is. Words like that, and it's over. And that's it. That thing right there will connect the thing. And whatever I type in will be known as words. That's its variable name. Then what I do is, I put the button down. This button right here. And I say, okay, input. Type equals button. Value, what's on the button?
Equals translate.
Translate. So that word translate will go on the button. And then you say on click, send, go up to this function, trans, and send this right here, this words, send words up there. With words, oops, dot value. You want to send, you don't want to send the word, you want to send the value of the words. And quote, and that. That's it. So what that does is that when you press that button right there, these words get sent up to here, arrive here as phrase. Then I take that phrase, add A to it, put it in Canadian. And then I take Canadian, and I send it to the translator, to the speaker, Canadian plus what language I want it to be spoken in, and then I say slash body slash HTML. There it is. That's it. That's the whole program. So basically, it's almost like the one we did the other day. The other one we did the other day, you just simply send a phrase up, and you simply say phrase in English. That's all we did. This time, we're adding a little bit of something to it. That's what I'm saying. You always have the capability of adding sounds or adding things. You know, you can do things after you learn how to do one thing and how to do another thing. You can put them both together. So instead of this just being saying the phrase, by using that plus sign, which we used early on, you can see you can add to it, add more to it. Then you send it to speak. In other words, it knows it's going to say this, and we just added a to it. It's going to say that too. You could have said, for example, just as a joke, you could say something like this. You could say space and what it would do then is, whatever phrase they say, it would say, you know, if they said, I like bananas, it would say, I like bananas is a dumb phrase. It would just add it on to it. So in other words, what it does is we're just simply adding more words to the words that are already there. So you see, you have some stuff here you can work with. It's not just one program, just one simple thing that translates this, and you can do stuff to it. There's a possibility of doing things to it, okay, which makes it much more interesting. Okay, so that's a program from last week. Now I'd like to get on to this week's stuff. This is the program where you type stuff to it, and it talks to you. Now we're going to do one where we talk to the program, and it prints out what you said in words, okay? By the way, this thing has improved enormously just over the last year. It's really improved an awful lot. In the beginning, if you said, hello, my name is Joe, and you look the other way for a second, it would lose some of the words. Now it picks up everything, and it really does it. And here's how they've done that. They've actually been very clever. What they do is they do statistics on all the programs. So, and they're especially good with words. Like for example, they've scanned all of works in the English language practically into they got a library of all the works in English. They've scanned them all in. Then what they did is they ran statistics against all those words. They say, how many times, for example, is the word banana used throughout history? And you can go online, and it will show you a chart. It will show you the numbers that increased and decreased over history in the books. All the books are dated. And it will tell you how often this word is used. And it's kind of interesting. Some words that I use every day have dropped off, and they aren't even on the chart anymore. And other words that I use very much are very high. A lot of people use them apparently in writing. This is all in writing. So Google spends a lot of time doing analysis of that. But in the process of analyzing that, they also analyze all the stuff you do online. And they look to see you have correcting, you're always correcting spelling and stuff like that. Well, actually, if enough people did it, we could make the corrector fail. And I believe the Americans have probably done that. There are words that I know are not spelled correctly in the dictionary, Google's dictionary. It's because Americans simply don't care how to spell stuff. And they've all collectively gotten together and agreed that you're going to put one L instead of two L's, and now the thing accepts that. That's the standard. So what it does is it kind of does statistics. So those same statistics in these speaking programs like you have on your telephone, it picks up that stuff, and you correct it. If you didn't like what they interpreted, you say it again. So you have to repeat stuff sometimes. And so basically, the computer says to you, "Did you say this?" And you say no. So it says, "Oh, that was the wrong word. Now say it again." So you say it again, and it picks it up, and it keeps taking all those things and putting them together and statistically analyzing them until it takes all the sounds, all the variations of sounds, whether you say something in a ski area or down hanging off a boat fishing or wherever you are, and it gets those sounds and it figures out this is really what you're saying, despite the background noise. It's able to subtract that because statistically it has lots of versions of that word. So now what they do is they've applied that to these programs, and now when you say something, no matter if you garble it or you're chewing peanuts or whatever you're doing, it will know what you're saying. It's very, very clever to figure that out. It's not perfect still, but it's as good as people. I mean, a person probably doesn't do any better than a machine does now, so we've gotten to that point. Anyway, so this is a program here that we want to do, the first one, and I'll just get it down and I'll explain every step of it as we do it. This is a program that's going to listen to you and type back on the screen what you said. Okay? Now this time you're going to use a different line up here. The last one, what Google was doing was taking what you typed in and turning it into sound. This one, this program we're going to put in now does something entirely different. It takes the sound you say and it sends back text. It does it the opposite way. Okay, so it's like this. Again, I'm going to get rid of all the Joe Darts and all that stuff. I'm just going to put the name of the program itself in. So listen. .js. That's the one that does it. That will do the job right there. And there we go, /script. See, so listen's different than the yellow one. What the yellow one did, as I said, repeating one more time, is you type stuff, it talks back to you. This one here, you talk, and it types back to you. So whatever you said, it catches. It sends it back to you. Yeah. Let me write the function first. I have to explain it a little bit too, so I'll write it down and then we'll talk about it. This is my variable. I made this up here. I just made that word up, okay? And I made up that one too. They're both just, this could be anything. I just called it listen. It could be called anything, okay? But I call it listen. I happen to call that listen too. It's coincidence. They're not related in any way. This is actually an official file that contains this stuff. This is what I call a function. Maybe I should name it. Let me call it something. Well, no, I can't because it's on a line like this. So I'll use this one. So listen is the function. I gave it that name, okay? And what happens is I create this variable right here called my words, and it equals transcription. I'll explain that in a second. And then I say, one value equals transcription words. And that's the end right there. Okay, now here's what happens. When this program first starts, it sees this thing right here. On its own, without you having to do anything, it turns on Google. It says, Google, listen to whatever they say. It starts it right away. You don't even have to do anything. That line actually contains the code that does that. Okay, so when the program starts, it automatically is now listening to everything you say. Okay, then, you start talking, and the screen starts doing this. We're going to put this big area up here, and down in here we're going to put this input area. It's going to say, like if I say hello, it'll say hello. In other words, whatever I say verbally, it will start writing it on the screen right across the input area. So in other words, it's giving back to me, Google's giving back to me my words in text. Okay? So here's what happens. You start off, you start saying stuff. Google's already listening to you. So immediately Google picks up the words you say, picks them up, and you don't have to do anything. And then what I have is, I work this out so that what happens is, Google then translates the stuff into into text. And it sends it back to me in this function right here. It comes back to listen. I named this function listen in Google, so it comes back to my function listen. And then what happens is it brings with it the words in text form. They're in text form now. So as when Google hears me talk, it translates it into text, jumps back to this function and brings this with it, which contains the words that are other words that I'm saying, only in text. Now, then immediately what I do is, this is something that's really weird. It's a technical thing. We have to do it, and I'll explain it to you, but just follow the rules and it'll be easy. Basically, I take that transcription and I put it into my words. I bring it to my own variable. This is their variable. That's built into Google. They throw this to me, and I pick it up and put it into my variable right away. Reason why is because Google's trying to figure out what you're saying. And as it figures it out, it keeps changing things. It keeps adding words and changing words and so forth. What happens is, eventually, it finally gets it straight, and the final answer comes out, and it's got the final answer. But here's the trouble. In a computer program, you can never have the same variable being talked to by two different people at the same time. In other words, you can't, as a user, right here with this program, with this function, I can't be doing stuff to transcription while Google is changing it to fix it at the same time. That's the thing it's working on. So therefore, you don't want to get into conflict with them. So what happens is, I grab their transcription, I grab what they have so far, bring it into my variable, then I can start doing stuff with it. Because it's in my variable now, and it ain't going to affect them at all. But if I started changing, adding something to it, or doing something to transcription, they and I would be doing something to the same variable. Very bad situation. You don't want that to happen. It only happens in very weird programs, by the way, because there are very few programs that are like this, where the thing, it's sending back to you a translation of what you just spoke to it. So anyways, just follow the rules of this. What I do is I say, okay, I have a function called listen, which you have to have in order to use this program. You have to have a listen function. And then you're going to receive that. Every time someone says something, you're going to receive that, which contains the words. But move it immediately to your variable, whatever you call it. You call it anything you want. I happen to call it my words, and call it anything you want. Then what I simply do is take my words and put it into alt1.value, which is down here, which is right here. That's all it is. Alt1.value is simply where it comes back to me. So at this point, that's what the whole function does. There's nothing else going on here. So if I write the rest of the program, I'll draw that now, that thing right there. It's slash script, slash body, slash head rather. And then body, I'll center it again. Body style equals text align center. You guys read my writing. Good luck if you can. Like so. I'm just aligning the text and center, that's all I'm doing here. Then finally what I do is I want to have an input statement. Input. And it's already called alt1. So I say type equals text. Text. And ID equals alt1. There it is. That's all there is to it. Body. HTML. Slash HTML. That's slash HTML right there. There it is, the program's over. There's really not much to it, because that's doing all the work for you. You don't have to do very much. What happens is, you say something to it, it listens to you and picks it up, goes back to listen with the transcription, puts that transcription in here. You immediately say, okay, put that in whatever variable I have, and then I can do anything I want with it. Right now, I'm going to put it into alt1. That's all I'm going to do. Very simple step. Make sense? Not too hard, huh? It's amazing. It's so easy to use, to tell you the truth, because you can't imagine what's behind the scenes here. There's a big bunch of stuff that you have to. It's technically the same stuff we're doing. It's just more of it, and it's very intricate, in and outs and all that stuff. So, and by the way, instead of using simple names, like I'm using simple names here, their names are all weird. It's just highly technical, crazy people. So basically, this is what we have. This simple little program does the job for us, and we can do lots of variations on it. There's a lot of things we can do. And so, let's see. One more thing I want to do. I'm running really fast today. That's good. Okay, let me explain some of these things to start with. You can run this program. It's on my file. You can run it. It's on today's list. But you can't write your own online. And the reason why is because this guy right here, when it's up on the server, will not talk to anybody's machine unless you have a secure socket layer in your host, and you don't have that. Okay, so there's no way you can do it. You can't just write this, put it online, unless you get a secure socket layer, which you could, but that you have to pay for, so don't do that. So basically, if you want to write this program so you actually can see it run, so you can actually test it and everything, or write your own even, if you put everything in your computer, it'll all work. So in other words, if this file right here was in your CS101 folder, and listen.js was in your CS101 folder, it would work fine.
Because it's like locally there?
Yeah, it's local. It doesn't, Google, if you're running it from yourself, Google doesn't care. They aren't concerned about it. But if you're trying to listen to somebody's microphone up online, down from a host, then they say, oh, wait a minute, you can't do that unless we know where you're coming from. Question?
Is this the reason why it only works if like that file is locally on your same like server or computer as like a security thing to prevent, like was mentioned before, like potentially like eavesdropping,
Yeah, that's right.
clandestine activities like that?
Because they get so many complaints that people would turn on, like if this, supposing this worked, okay, once you turn this thing on, once they say I accept, there's a little button going to come up and say, do you accept people listening to your microphone? They say yes. Once they say that, it's like that all day, and it ain't going to stop unless we shut it off somehow. And this program doesn't shut it off; it just lets it on. So therefore, if anyone could get into that feed, they would be able to listen to everything that's going on in your house for the rest of the day until you shut your machine off. Okay. So Google got tired of that happening, and they got tired of it with video too. So both of those things, they don't allow you anymore to, without a secure socket, to listen or to watch, to eavesdrop. And it's justifiable. They basically, from experience, they realize it just wasn't a good thing. However, it gets in the way of a little class like this because I would like to have you be able to do this stuff. And the first 2 years of this style of class, we were able to do it. Sometimes Firefox will do it for you. It'll run programs, Google programs, believe it or not, and it will actually, everything will work. Because at least they didn't up until the summer, they hadn't put any kind of protections that everybody's kind of agreed to now. So they still may run it. And it may run also on, what's the name of the browser for Mac? What's your Mac
Safari?
browser? What?
Safari?
Safari, yeah. It might run it too. Because I think the other browsers, they aren't so concerned about Google stuff. So they probably just,
Google Chrome,
that's in the back burner or something.